students, welcome to Easy BTech, your guide for BTech and beyond. The today's topic, we will discuss about transistor action, how the transistor can be performed in active region. Okay, transistor can act as a amplifier in an active region only. That is why we will call it as an excellent action can be takes place during a active region. Now, what is an active region means in the mode of operation we have clearly studied the mode of operations. We have clearly studied what is a an active region means emitter base junction is a forward bias and base collector junction must be operated in reverse bias such that maximum of charge carriers can reaches from emitter to collector. Okay, students. Today we will discuss these topics in detail, and one important factor is here, or one important is BJT is known as bipolar. Why it is named as a bipolar, we will see here in detail, and why BJT is known as current control device. The two concepts we can clearly understand through today's session. Okay, students, we will discuss today BJT operated in active region for excellent transistor action, for excellent transistor action. BJT has two junctions. Number one, JE forward bias. Next, JC, this reverse bias. JE junction in forward bias, JC junction in reverse bias. That we will discuss today clearly. This is JE junction, this is JC junction, this emitter base collector constructed from PNP transistor. Okay, it is forward bias, it is reverse bias. It means positive connected to positive forward and negative connected to negative. This JE junction in forward bias, and positive connected to negative and negative connected to positive, then it is reverse bias. JC junction is operated in reverse bias as per this concept. Then the transistor is operated in active region. Okay, we know that emitter is heavily doped semiconductor. Base is lightly doped semiconductor. And collector is moderately doped. That we have discussed. That is 1 part in 10 power 3. It is heavily doped. 1 part in 10 power 6 to 8. It is moderate doped. 1 part in 10 power 8 to 11. It is lightly doped. That we have discussed in the previous session also. Now as the emitter is heavily doped, as emitter region is heavily doped, more amount of the charge emissions can be takes place. More amount of the charges emission can be takes place, and then it can reach us to the collector. That is an action. Means as the emitter is heavily doped, more amount of the charges can reach us to the collector. Is it clear? Okay. As base is lightly doped, whatever the charges emitting from this emitter, lesser recombination can be takes place within the base, and remaining can enters into the collector region. That is why the base is lightly doped and the collector is moderately doped. Why the collector is moderately doped means during the reverse bias, as the reverse bias voltage increases, reverse saturation current will increases, due to which smaller reverse voltage, larger reverse current can flow. That may damages the transistor. That is why we cannot make the collector for an heavily doped. That is why we are making into a moderate dope only. These are the cases. Now you can clearly study during the forward bias. The charges, what you can say? During the forward bias, during JE junction is operated in forward bias, more amount of holes, that is majority carriers crosses the JE junction, enters into the base region, and electrons from the base region crosses the junction, enters into the emitter region. Okay. Current from emitter to base. Current from emitter to base across the JE junction is known as IPE. Current from base to emitter region, across the JE junction, it is known as INE. Therefore, emitter is heavily doped semiconductor compared to base region, compared to base region, that is IPE is far greater than INE. IPE is far greater than INE. Now you can see here, due to this forward bias, now positive connected to positive, holes from this side crosses and enters into this junction in the form of IPE. And due to this negative connected to negative, it is a forward bias, and from here more amount of current entering into this side. This will represent as an INE. And due to emitter is heavily doped, this IPE is much greater than INE. IPE much greater than INE because of their doping, because of this. This is for emitter, this is for collector, this is for base. IPE is much greater than INE. Now, what happens next? You understand? This is the concept. Next, what happens? Due to base is a N-type region, due to base is a N-type region, charges from emitter, that is IPE, due to base is an N-type region, charges from emitter, that is IPE, will recombine with the electrons present in N-type base. Okay. Now see here. Now, due to N is a majority charge carrier in our electrons, electrons will recombine with this current. Now suppose 100 holes are flowing from emitter to base. Now only 5% can recombine with these electrons presented in the base. Remaining 95% enters into this collector region in the form of current IPC. Because only less amount of due to that region, that is base is lightly doped, only lesser amount of the charges presented in the base, lesser recombination takes place. That is why the charges can enter into the collector region. Due to base is lightly doped, few holes recombines with electrons in the base, and remaining holes crosses the junction and enters into P side of the collector region in the form of IPC current. Okay. Now lesser recombination takes place, remaining enters into the collector region in the form of current IPC. Therefore the current in the base region is entering current IB is equal to entering current is IPE and leaving current is IPC. The entering current is IPE and the leaving current is IPC. Now you can see if we will see here. This is JE junction, it is JC junction, it is emitter, it is base and collector P, N, P. Okay, now you can see here. Now you can see here. Already in the previous we can understand here. The current here to here is IPE and the current here to here is INE and the current from here to here is IPC. These all are majority current. IPE and IPC are majority currents. But IPC is the minority in the base. IPC is minority in the base. Okay, now you can see here. Now you can see here clearly during the forward bias, these all are forward bias current. Now, if more negative is given, if base is supplied with more negative potential, then base becomes negative and attracts more holes from the emitter region. Therefore, larger recombination takes place inside the base region. Then lesser amount of holes will enter into the collector region, into the collector region. Now it is very clear, as if you supply more negative voltage, if you supply more negative voltage to the base, then lesser recombination, more recombination will takes place, larger recombination takes place within the base, and a lesser amount of the charge from here to here, then IPC count will be decreases, then lesser current enters into the collector, which is a undesired condition, undesired condition, which is a undesired condition. Clear? As more negative is given to the base, base will become more negative, whatever the charges are coming from emitter to base. Now the more recombination takes place in the base, lesser amount of the holes crosses the collector junction and reaches into the collector, which is an undesired. Okay. Next, similarly, if base is made more positive, if base is made more positive potential, if base is made more positive potential, then base becomes positive, base becomes positive, then lesser amount of holes flows from emitter to base because of similar charge carriers. Okay. When base becomes positive, which opposes holes from emitter to base, then no charges flows from base to collector. It is not a transistor action. It is also undesired. It is a undesired condition. So, undesired condition. Now you can see here, if you supply more positives, then it becomes all positive. Then whatever the charges are coming here, it opposes, and there is no movement. There is no movement from emitter to collector. There is no movement between emitter to collector. No charge flow. That is not a transistor action. That is the reason base current is compensated. Base current is compensated or neutralized to flow the emitter current into the collector region, BJT is known as current control device, because the current in the transistor is decided by the base current. Okay, BJT is known as current control device because the current in the transistor is decided by the base current. Now you can see if base is heavily doped means if a region, you can clearly see here, if more negative is applied, lesser movement. If more positive will applied, no movement from the emitter to collector. That is not a transistor action. That is why this base current will decide. This base current will decide the amount of current flow between emitter to collector. Okay, that is why it is a current control device. Next, when JC is operated in reverse bias, the current flow through the collector junction is IPC is a majority current. IPC is a majority current from emitter to collector via base, and IC naught is a reverse saturation current. Or we call as a minority current. Now you can see across the collector junction, we have both the current. Now you can see here, when it is operated in reverse bias. Now due to this reverse bias voltage increase, now the current across this collector junction is IC naught current. IC naught is nothing but reverse saturation current. And when it is in forward bias, the current from this emitter to base and from base to collector, that will represent as an IPC current. This is a majority current. It means across the collector junction, we have both majority and minority currents. Okay. The current flow in the transistor is due to majority and minority current. That is the region. BJT is known as current control device. BJT is known as current control, and BJT is known as bipolar device. Why it is named bipolar means across the collector junction, we have the majority current and minority current. This current flow through the transistor is decided by both the current, majority current and minority current. That is why it is named as a bipolar device. Next, transport factor. Transport factor. Now we will represent this transport factor as alpha T or beta star. These are the transport factor. Alpha T is equal to the current, that is the current entering from this, the current entering to the collector, that current is we will call as a IPC current, and the current entering from this emitter region, that is IPE. It is a, what we will call, alpha T is equal to IPC by IPE. It is a ratio of current entering into the collector region to, it is a ratio of current leaving from the emitter region. It is a ratio of current entering into the collector region to the current leaving the emitter region. That is why it is a transport factor. It can be represented in that. Okay, now we will represent. We know that IE is equal to IPE plus INE. Across the collector junction, across the emitter junction, the current is IPE and INE. We know that IPE is far greater than INE. Now we simply write IE is equal to IPE. And emitter efficiency, across the emitter efficiency, you can see here clearly. Now you can clearly understand here. Now what is the emitter efficiency? Emitter efficiency can be represented as the current entering to the base to this region, that we can represent that is efficiency, emitter efficiency is equal to current entering, majority current, maximum current, IPE by across the emitter region, that is IE. That we simply call as an IPE, where IE is nothing but IPE plus INE. Means it is slightly less than 1. Emitter efficiency is slightly less than 1. That is, suppose 99 by 99 plus 1. We can assume it is a 0.99. It is the value of emitter efficiency. Now if you substitute this in a transport factor, we will write alpha T is equal to IPC by, this we will represent IPE as IPE and IPE by IE. Now IPE will get cancelled. We will write alpha T is nothing but this IPC by IPE. We will write as a beta into this IPE by IE. IPE by IE emitter. Simply we write alpha T is equal to beta star into gamma. This is also one of the formula. Because we will write this in this IPC by this current IE. This we will write in this manner. It is an emitter efficiency. From the emitter junction, majority current is IPE and the net current of emitter is IE. By substituting, we will get this value. These are the transport factor. Therefore, the base current across the base current is current leaving is IPE, means from emitter to base entering current is IPE and leaving current is IPC. From the base, this is known as a base current, base recombination current, base recombination current. Because emitter to base entering is IPE and current from a base to emitter, base to collector is IPC and it is a minority current. That is why it is represented with minus. Because in base the majority charge carriers are electrons, but holes leaving minority current. That is why we represent this with a minus. Okay. Next, expression for collector current. Expression for collector. We know that when emitter junction is in reverse bias, IC is equal to entering current, that is minus IPC. It is a current entering into this collector junction, that is a majority current, plus we know that reverse saturation current IC naught. It is a majority current and it is a minority current across the collector junction. And we know that alpha is equal to IPC by IE. Now if you write this, IPC is equal to alpha into IE minus alpha into IE plus IC naught. Current in the transistor is due to that is IE, emitter current, base current and collector current is equal to 0. Now the emitter current we will write as minus IB plus IC for an NPNP transistor. Now this you can substitute in this equation 1. Assume it is an equation 1. This equation. Substitute 2 in 1. Okay, what you are getting? IC is equal to minus alpha into IE. In place of IE, write minus IB plus IC plus IC naught. Now this minus becomes plus alpha IB plus alpha IC plus IC naught. Now this you bring this side, IC minus alpha IC is equal to alpha IB plus IC naught. Make the IC common. IC 1 minus alpha is equal to alpha IB plus IC naught. Now from this you write IC is equal to alpha by 1 minus alpha IB plus 1 by 1 minus alpha into IC naught. We know that from the alpha, beta, gamma relationship, alpha, beta and gamma relationship, alpha is equal to beta by 1 plus beta, theta is equal to alpha by 1 minus alpha, gamma is equal to 1 by 1 minus alpha, gamma is equal to 1 plus beta. That's the relationship. Now from this, if these two are equal, then we will write a 1 by 1 minus alpha is equal to 1 plus beta. In this place we will write this from this gamma. Now we will write a IC is equal to alpha by 1 minus alpha into IB plus 1 by 1 minus alpha can be written as 1 plus beta into IC naught. IC is equal to this alpha by 1 minus alpha beta IB plus 1 plus beta into IC naught. This is the total collector current. Total collector current. Okay, students. In this today's session, we discussed how the transistor can act as an amplifier and how the transistor can be operated in active region, how the transistor is known as current control device, how the transistor is known as a bipolar device. Easy BTech guide for BTech and behind.